is in 2, this is 1, minus 1, minus 2, 2.5, 4.5, 6.5. He has given the wave velocity. Himself he has given plus 40 centimeter per second. First thing, find the, this is a y-x graph, it is in centimeter. Find first one F, second one phase difference between points. How long does it take for the phase at a given point? Given position to change by 60 degrees. Find the velocity of point P at the instant shown. Okay, now he's asking some new things. Okay, he has given wave speed and he has given some dimensions. Huh? He didn't mention further earlier what can be this. Okay, 2.5, 4.5, 6.5. So like that we can go further, 8.5 like that. So what do you mean by wave speed? This is 40 centimeter per second plus 40. What does it mean? The wave is propagating along positive x-axis. The wave is propagating along positive x-axis. How the various points on a rope will be moving? So they should be moving up. Okay, now so now we know can we get the wavelength? Distance between 2 points on a string. Distance between 2 points on a string which will have same phase. I think 2.5, 6 points. They're having same phase. So I'll take this as to be lambda. What is lambda? 6.5 centimeter. This will be the lambda. Okay, lambda, I got it. So from lambda, I'll bring k. 2 pi by lambda. If you know k and if you know v, we'll get the omega. If you know omega, from that I'll bring the frequency. Okay, no, the first thing is what? We brought it. Okay, there's the frequency. Next, the phase difference between 2 points, 2.5 centimeter apart. So what formula I should take it? I should go for this formula. Delta phi equal to, okay, can you remember this? So 2 pi, lambda is how much? 4. What is the separation between them? Which are 2.5. 5 pi by 4 is the phase angle between them. Next, what is asking, how long does it take for the phase at a given position to change by 60 degree? What is the meaning of this? Already I explained concept is asking a little bit of a given at a given position. So let me underline. Of a given point on a rope, anything, how long does it take for the phase at a given point on a rope to change by 60 degree, or at a given position to change by 60 degree? What do you mean by this? See, what is the point on a rope? It will execute SHM, no? So let's assume that it is at mean position. It is moving up, zero phase. This point will go up. As it moves up, phase will increase, no? So it will become from 0, pi by 2, pi, 3 pi by 2, then 2 pi. So at a given point, what's happening? The phase is varying with the time. Go back to SHM. Then what is the formula? I do have a formula, delta phi. But we don't know time period. As we know frequency. From frequency, we'll bring the time period. 2 pi. This will be time period will be 1 by 10. Delta t. How long does it take? So the phase angle is given 60 degrees. 60 degree means what we write? Pi by 3. So shall we write that as 60 seconds? Getting the idea, no? So at a given point, you can take any pointer, not only point P, any point here. Like, how long does it take? How long does it take for the phase at a given point position to change by 60 degrees? There's a formula. So we are not understanding from where you brought it. See, it's very simple. You need not to fight with mathematics. Go back to SHM. So if it completes one oscillation, tell me how much of phase it will gain? 2 pi radian. For one oscillation, what is the time period it will take? Capital T. So right here, capital T, 2 pi. If it completes, if it moves from mean to extreme, what is the time it will take? T by 4, substitute here T by 4. So how much of phase it will gain? From 0, the phase will increase, will become pi by 2. Then again returns back pi, 3 pi by 2, 2 pi. Okay, I don't want to trouble students through mathematics, just a simple like we know SHM. So as the particle moves from mean to upper extreme, again mean, again lower extreme, its phase will change from 0 to 2 pi.
So delta t is 1 by 60.
Okay, this one, 1 by 60, yeah, fine. Okay, this one. Find the velocity of point P at the instant shown. Okay, how to get the velocity of point P? I think it's quite clear, no? We know amplitude, how much? 2 centimeter. Do we know omega? Yes, we know omega. So what is the velocity of point P? Velocity of point P is given by A into omega. 2 centimeter. Omega is how much we are having? 20 pi, 40 pi centimeter per second. This is the velocity of point P. Then can we write the phase angle? Because we don't have further information. Is this the shape of the rope at t equals 0? Am I right? So therefore, I'm not going for the phase angle. If he has given that it is at t equals 0, okay, we'll go for it. If it is at t equals 0 means, yes, I know what is the value of y at t equals 0. It is minus 1 centimeter. So with this, I'm able to predict the shape of the rope. He didn't say that at what instant of time there's the shape of the string. So therefore, writing phase will be a little bit difficult here. Getting some idea? You have to work out some problems. So some questions, they'll give diagram. Some questions, the first three questions, no, without diagram, I brought it. Mains means will be of that kind where they don't give diagram. Advanced, no, they'll try to prefer to ask through a diagram. Okay, students, what happen? They'll be asked a diagram. So from diagram, they may ask you some questions here. Any doubt till here? What all we discussed? If you have, you can clarify it. Any doubt? If you have, you can clarify. What is this? Speed of say in books open, they just say medium. Medium, they say that one. For our understanding purpose, we call that medium as a rope or a string because this will help us a lot. Because medium will start trying to imagine. Need not. Just the rope itself, what happen will be in the form of a sine wave. When a transverse wave propagates on a rope. So string or a rope or some books they call a cord also. Will maximum books they use string. So very frequently we are using rope here. But if you look at the books, no, they called sometimes medium also. So nothing. What is a medium? The rope itself is called as a medium. So if you look at the books, no, so several books they used. Now, any doubt? If you have, you can clarify it. Okay, we'll end up the class. Tomorrow we'll start at 8 o'clock. Huh? Today I could not start earlier.
Thank you, sir.
Thank you, sir.
Thank you, sir.